Okay, today we're going to talk about a different version of my celebration dancing robot. This was the first version, which you've already seen a demo of if you've watched my channel in the build video. And then Ozzy commented on those videos and wondered whether I could do his logo from his museum. So I did this version with his Bilotta collectible or collection, which is Ozzy Bilotta's last name. And I also didn't want to just make this sign, which I'll tell you how I did. I also wanted to make a few changes to the robot. The original design, I used a TT gear motor because they're so inexpensive, anywhere from $1 to $2. This one I'm going to use the N20 type motor, and I'll show you that in a second. But they're about five to 6 times more expensive, anywhere from 10 to 12 bucks a piece. But they're much smaller. And because they're smaller, that means I could make changes to the body. I didn't need the backpack anymore. I could actually put the switch in the body. I've got a lot of hollow space for cramming in the wires. I decided to make some changes to the legs, added some knees, thickened up these joints up here around the cam and where the cam followers connect. They're much beefier. Added some heels to the shoes, both for cosmetic and for strength reasons. And these heels can be added to the original design. You can see they glue on the bottom and they go up over the edge and hold support there. Of course, if you've assembled the robot using the proper glue, as I've told you to use in the past, it actually melts the PLA together. You don't need the extra support, so in my case I'm doing it for cosmetic reasons. And in action, this little guy is going like that. He's really twisting up a storm. This particular motor, they sell the N20 type motors in different gear ratios, and it gets confusing because at different voltages you're going to get different RPM, different speeds. This particular one that I'm using here was sold as a 6-volt N20 with 250, if I remember right, RPM. That's no load. So I'm running on 3 volts, so figured half of that, so closer to 120 revolutions a minute, or 2 revolutions per second, no load. With a little bit of a load, it's going to go slower. I really think they only make 3 different versions of the standard N20 type motor, and they just, when you see all these different speeds and RPMs and everything, it's just based by how much voltage they're hitting the motor with. So it can get confusing. I'm going to tip this camera down a little bit more. So here we can see this pile of guts, and here in fact is the type of motor I'm talking about, commonly known as an N20, but they're also sold under different maker names and different gear names. If you just go on Amazon and look up for small DC gear motors or N20 motors or something like that, once you get into this you'll find all kinds of them, and then you'll see what I'm talking about on the different RPMs and gear ratios versus voltage. The really good sellers actually have a complete chart that show all the voltages versus what the RPM is going to be coming out of the thing. Now, this is going to be an assembly video. It should go much faster than the video that I did for this original one with the TT type motor, because in this one I was very thorough and went through everything. Took about an hour. This one, as you can see, I've pre-prepped, I've pre-wired everything, and many of the parts I've already pre-glued that had to be glued. For example, the leg units, because they print in 2 halves, already glued together. They already have the sole on there. I already have the battery connectors in there. I already have the wires run, and all of that would have taken more time. Nice thing about this new design also means I can run the wires all internally. I don't have to run any up the back because the motor's so small. So you can see the body is going to be a little bit different. It's simplified. Now this slot here is where the motor's going to push in. The motor's going to fit very tight. If your printer does a bad job of bridging, you may have to go in there and clean things up to get it to fit. But you don't want to leave any debris or anything in there, because on these TT motors the gears are exposed, and if you get a little chunk of something in there, you're going to bind up your motor. So you take your motor, this is the back, body back, stuff it in there and just push it till it comes all the way to the front, until it's sticking out the front. And then the wires can poke into this hole. In the end, we're going to glue a little cap on that, and the cap does 2 things. One is it hides the wires, but 2, it keeps the motor from ever being able to be pushed back out of the way. Alright, there is a left and a right leg, of course, and you have to make sure that you put on the right leg first. Well, right in the picture, left to the robot. So this leg that I'm holding right here is slip it up over the shaft and down here, and we're gonna pin it. But this is the robot's left leg, even though it's on the right side of the frame. And again, this one I'm just going to use some, I believe these are tar paper nails. I was trying to think of what type of little nails that I had found out in the shop to use. Oops, dropped one. I think they're meant for holding tar paper down on a roof before you apply the shingles. At any rate, I've cut them so that when they go in both sides of the legs, they won't hit, so they can go in all the way. And just to hold them in place, I'm going to take a little bit of the E6000, which is good for joining dissimilar materials, like anything that isn't plastic to plastic. And put a little bit around the nail head, actually put more around there than I meant to. And let's just find the hole and jam that one in. Okay. Then I've got all this wiring, which is covered in the build video for the TT type. And it basically stays the same, other than this one I get to jam it in there. And slip that over the motor shaft, then down to here. Let's glue that pin in. Like I say, I'm purposely going quick here because a lot of this is already covered in detail in the other build video. I will put a link to the other build video in the description box down below this video, because even though the legs and the body are different, the basic build instructions are the same. And take these wires and I'm going to try and pull them on up. If I can get the extra wires up in the body. You can see how nice it is to have a nice big hollow body now. If I can do it without yanking any of my solder connections off. I think I'm doing it. There. So I can get the wires from the motors tucked up into that hole. I'm going to pin the back side of the legs. Again, if you don't want to use finishing nails or large paper clips, all things that you could use to pin these legs in place, you can also use number 2 screws, and you can screw it together, which I did on one of the TT build ones, just to see if you can do that. If the screw is a little bit tight on the part that's supposed to move free, the leg for example, and of course you can always drill or ream that out. Okay, good. So now we have that. I think before we go any further, if you've already wired yours and kind of got things hanging like I do, you want to make sure stuff works. And in order to do that, I'm going to have to put a couple batteries in there. Like so. I seem to have a battery contact problem. Okay, so the motor is turning, as you can see. In my case, I had the 2 red LEDs in the head. I noticed another builder on Thingiverse has used green LEDs, and they look really nice. Red LEDs have a slightly lower voltage on point. The green LEDs should work fine. Blue and white LEDs have a much higher voltage turn on point where they need almost the full 3 volts before they start working. So I wouldn't recommend using the blue or the white unless they have their own inverter driver circuit. And actually, believe it or not, they do sell them that way, where they'll work at a much lower voltage because they already have a driver built in. What I'm doing now, and it's kind of my hands are in the way, I realize that, so I'm cramming all the extra wire in because I'm going to go ahead and glue the top of the body down to get that out of the way. And to do that, I'm using the weld on number 16. Just put a few dots of it on the inside of the shoulder part here. How the shoulder part assembles, again, is covered in the other video. I guess I want to cap this glue before I have it drying out in the tube. It's covered in the other video, the full build video. I want to get that down on there. Like so. Okay, next thing we're going to put on is going to be the cam. And because this is a different motor and different size shaft, of course the cam is a little different. It had to be a little bit deeper, and of course the center hole has to be different in order to mate up with the new motor. But clean that around and line up the leg parts and just push that cam on in there. There we go. So now let's test the cam. Alright, there's our first part going. Got the hip action. Other nice thing about the small TT motors, other than, well, the high price isn't a nice thing, but is that, trying to get this camera centered a little better, so they only draw about 30 or 40 milliamps at 3 volts to do this, so your battery run life will be quite long. Arms. I think it's time to put the arms in. Okay. So I've already pre-assembled the arms, which means I've taken some of those tar paper roofing nails and pinned these two parts together so everything should be free moving, like so. I should clean this center hole out a little bit. I've got to find my X-Acto. There it is. It's kind of invaluable for cleaning out little holes. I saw some stuff there which could cause a problem later. Clean that out. And these are just going to fit up into the shoulders. And we should be able to just pin them. Now if I cut the pins too long, we may have to shorten them, because these haven't been tried yet. It looks like it might be a tad bit too long. I think I might be better off snipping those. For that I always keep a big old pair of dikes around. I'm just going to take about another 1/8 of an inch off these to make sure that it's going to go all the way down in there. Alright, arm, shoulder. There we go. And of course, if you're worried about these coming out, we can do the same trick. We can put a little bit of glue around the head, which I should have on that other one. I will on this. And I may just pull that other one out and put just a little bit around there so I know this isn't ever going to fall out. Like if I were to ship this to Aussie, I wouldn't want it falling apart on the way there. Not quite sure why that's not dropping down in there. I didn't check the hole in the body. It could be that it might need to be clean. There we go. Now let's go ahead and lift this other one out, because I wouldn't want to have to try to remember to come back and glue that later. I better just do it now while we're talking about it. And just put just a little bit of snot around the head area there. Just something to bind it all together. Okay, so now we got our arms, we got our head. What's missing now Okay, it's going to go on the back later. We've got this cam follower, and it's a little bit different as well. It has a bit of a cutout that the original didn't have. And I'm going to pull the nail out so that we can assemble this on here. I haven't this part could be glued or it could be screwed. It's kind of up to you. Since I do have the screws, I'm going to try and just screw it in with some 632 screws here in America. But there's no reason you couldn't just glue this part. Just line it up with the holes and there's that one. Okay, so now you can see it went over, follows this smaller cam, and the reason that this small cam is small is if you make it large, you get less movement. I want a lot of arm movement, so that size is important. And then there's all these bits up here that you need to line up. I'm gonna turn this more or less top center to get all this together, because you want the head and the arms and all of that to line up with this riffing nail, which I've cut the end off. I'm going to go ahead and leave the head part on there. I don't think that's going to hurt anything, but it's going to go right down into the end of that cam arm that we just screwed in place, like so. And there we go. So the main thing that started this whole build with this different motor type is because Ozzy said, can you make one with a sign? So I already showed you the this one back here, the red one, but I also tried it with a white background and red letters. Now how I made that is, basically I went to YouTube and went to Ozzy's site, and I saw his logo part there. So I grabbed that logo part, and then I went to Images to Lithophane, which is 3DP Rocks. It's a website that I use for making my lithophanes. They inputted that image into that. Went for the flat, because you can do flat, curves, all kinds of different things. Went for the flat. Told it to make it 3 millimeters at the thickest, so anything that's super dark will be 3, and anything that's white will be like 0.8, less than 1 millimeter thick. And it basically turned it into that. Let's here's a view of the final piece here, and we're in 3D Builder, which is a free program if you have a Windows type computer. It's very handy to have, because even if you made a blank panel and you wanted to put text on it, like when I did Be My Valentine, you can just go up and once you're into this program, let's click this here. Here's your choices now. Under Edit, you can go up and you can emboss, and you can add text and stuff to things, and you can decide how raised you want it and how raised you don't. And you can also add circles and loops, and you can punch holes and stuff. It's a very useful program. So that's where I turned his logo into the 3D Lithophane website to give me the relief, and then this website so I could size it and add my hoops and holes. And there you have it. So I've got this little guy here now. Let's see. Let's get you focused back down here. And what I'm going to do now is just take needle nose. I've made little hoops out of paper clips with straight ends. My idea is I'm just going to run it up through the hole in the hand all the way up, pinch it with the needle nose, and bend it forward so it can't fall out on its own, like so. I'll show you a close-up here, like that. Just took it and bent it. Then I'm just going to snip off all the excess. Of course, if you don't like those little parts aiming forward, you could always bend them to the back. Okay, now on the back we still have this little cover piece which can go over the motor. You could either glue it vertically or horizontally, whichever way suits you. I'm going to go vertically because when I was laying it out, that's what I had in mind. Like I say, one, it hides the wire connections so they don't get broken, and two, it'll keep that motor from ever getting pushed back accidentally. Now don't go crazy with the glue here in case I ever had to bust this thing apart. Of course, being that all the parts are just 3D printed, if I did ruin something, I could just print a new one. So there's how the back looks now. It's got the beefier rear legs. Unfortunately, these beefier legs won't work on the TT type version because on it I have a channel where I run wires up. So if you wanted to use these beefier legs on that one, you'd either have to cut off a little bit of this round part of the beef, or you'd have to cut off that channel that's on the back of the body and just let the wires kind of tuck up through there. Then you could run these beefier legs that have the knees and got all that good stuff. Alright, I believe that's it. So there you have it. There's version 2 of the Celebration Dancing Robot. In this case, it's celebrating Ozzy Bilotta's Toy Museum. And this is using the N20 style motors versus back here I had the, let's make some more room. Back here we have the TT type gear motor. Much less expensive to build. Not that hard to find the TT motors, you can still find them. But this is perhaps cosmetically a nicer looking, and this is the higher speed. Like I said, they were selling it as a 6-volt, 250 RPM motor, which we're running on 3 volts, so figure it's somewhere around 120 RPMs at 3 volts. Whatever, I think you could even go with their slower one. They have a, what is their slowest one? It was about half that. It was like 150 or 120 RPM at 6, so then you'd be down to 1 cycle per second. Probably closer to this, because this is about 1 complete revolution per second. So I think you'd even go with their slower one if you wanted to.